Good afternoon, students. Today we are going to see operating system concepts and process concepts in operating system. What is an operating system? A program that acts as an intermediary between the user and the computer hardware. And the goal of the operating system is it can execute user programs very easily and the user can conveniently use the system. The computer hardware needs to be efficiently used by the user. The components of computer system is basically hardware, operating system, application programs and users. So what is hardware? All the types of resources, basic resources what we are using in a system is called as hardware. CPU, memory and input-output devices. And what is an operating system? So the operating system is going to control the user, the application program and the hardware, and it is going to coordinate with the all users. And what is an application programs? A problem needs to be executed with the help of the application programs by the user. And what is a user? People and machines were called as users. So this is the abstract view of system components. You can see that the operating system lies between the computer hardware and all the users. The more number of users can be used this computer hardware and the operating system, and the user may be using any system programs or application programs. The assembler, compiler, text editor, database systems are called as system programs. Like Word, Excel, PowerPoint are called as application programs. The user may be using any of these programs. And the operating system can be defined as resource allocator. What is meant by resource allocator? The resources like CPU, memory, I/O devices needs to be allocated by the operating system. That's why it is called as resource allocator. It can also be called as a control program. So what is meant by control program? It is going to control all the programs and operations of I/O devices. That's why OS is called as control program. And it is also called as kernel. So what is meant by a kernel? Even though the it's also a program, even though the application program stops its execution, the kernel may be running at the behind. So without kernel we cannot use any of the operating system programs. And the types of operating systems. The first type is mainframe systems. As you all know, IBM is most popular for using mainframe systems. The main advantage is it reduces the setup time because it is going to batch the group of jobs and execute it. That's why the time gets reduced. And it also has the feature of automatic job sequencing. What is automatic job sequencing? Automatically when one job gets executed, it will be transferred to another job. And it also has resident monitor. The resident monitor controls all the execution of programs. So the initial control will be with the monitor. The monitor will give transfer the controls to some job which needs to be executed, and after execution job again the control transfers to back to monitor. So everything is controlled by the resident monitor which is inside the IBM mainframe or mainframe systems. And this is the memory layout for a simple batch system. So mainframe system can be divided into simple batch system or multi-programmed batch system. So in a simple batch system you can have only one batch program which can be used in the user program area, which is controlled by the operating system. And this is the diagrammatic representation of the multi-programmed batch system. Here you are seeing more number of jobs in the user area and one space for operating system. So the operating system will help the CPU to multiplex between all the jobs whichever stored in the user program area. That means at the same time many programs can be executed in the mainframe system. And time sharing system. So time sharing system is the job will be swapped in and out of the disk and memory. That is, whenever the job is needed, the OS will help the CPU to get the job from disk to memory, and whenever the job gets executed, again the job will be transferred to the disk from memory. So this work is done by the operating system, and a particular time slot will be allotted for each and every process, and after the time slot gets over, it will be swapped in and out. And this is desktop system. The next type is desktop system. We are all using desktop system, that is, it is otherwise called as personal computers. Every home will have a personal computers nowadays. So even though it is a personal computer, it is particularly used by a single user, it also needs I/O devices like keyboards, mouse, display screens and printers. We can attach all these things and we can do all the works. And the main advantage of using this desktop system is user convenience and responsiveness. That means a single user wants to do whatever he wants. If he is in LAN, he will be controlled by the server. But in a desktop system or personal computers, he will not be controlled by any servers. He is a single user and he can do whatever job he want to execute and may run several different types of operating system. A personal computer can have any number of operating systems like Windows, Mac OS, Unix and Linux. And the next type of system is parallel system. So parallel system is otherwise called as multi-processor systems. That means more number of processors will be there and all the processors will be executing at the same time many jobs. It is otherwise called as tightly coupled system. Tightly coupled system is nothing but they are going to share memory and a clock. So it can also share the jobs needs to be executed at the same time with the same memory and a clock. And the advantages of parallel system is increased throughput and economical. How it is economical? Instead of doing separately each and every job, we are doing it at the same time with the shared memory and clock. That's why it is very economical and the output is also very much increased because at the same time we are getting more number of outputs from more jobs. And a parallel system is defined as two types. One is asymmetric multiprocessing, another one is symmetric multiprocessing. Asymmetric multiprocessing, each processor is given a specified task and you will have a master-slave processes. Master is going to assign a job for a particular process and the slaves are going to execute it. And it is mainly used in large system and it is used for large application programs. And what is symmetric multiprocessing? Symmetric multiprocessing in that each process runs an identical copy. It has its own copy of the operating system and many processes can run at the same time without performance degradation. And this is the diagrammatic representation of symmetric multiprocessing architecture. You can see that more number of CPUs connected to a memory. Anytime the jobs can be swapped in and swapped out and or even the jobs can be executed at the same time in the multiple CPUs. And the next type is distributed systems. Distributed system is what we are using as client server systems or called, that is our internet is called as a distributed system. That means the client is going to request a particular page and the server is going to process it and it is going to give you the response. The best example is railway reservation. So the client in his own home or in some center, he is going to register for a particular train, he is going to reserve for a particular train and he is going to ask the server whether the reservation is available, seats are available or not, and the server will process the request and sends to the client system the results that whether the availability is there or not. So that is possible with the help of internet. So any person in any place, he can able to communicate with the server and get the necessary data. That is the distributed system. For that, the mainly needed thing is some telephone lines or high speed buses or any network is needed. So network, it could be a LAN network, WAN network or a MAN network. LAN network is local area network, WAN network is wide area network and MAN is the metropolitan area network. So any type of network is needed to pass this information from client to server. So that is called as distributed system. The information is distributed to more than one system. And what is the advantage of distributed system is the resource will be shared to many systems and the speed will be increased and also the communication is taking place from one system to another system and it is also reliable. And it is otherwise called as a loosely coupled system. What is loosely coupled system is each processor has its own local memory and own connections will be there. That's why it is loosely coupled systems. And this is the diagrammatic representation of the client and the server, and it is also called as peer-to-peer network. Client server system is otherwise called as peer-to-peer network. And the next type is clustered system. The clustering allows, what is meant by clustering? Grouping together. So clustering allows two or more systems to share the storage. Instead of storing it in a separate server, we are going to use two or more systems to share the storage. It also provides high reliability because the information stored system will be secured one, so high reliability will be there. And you have two types again, asymmetric clustering and symmetric clustering. Asymmetric clustering is one server will be running the application, all other servers will be in standby. That is asymmetric clustering. Asymmetric means only one system can execute the process. So that's why one system is executing, others are standby. And the next type of symmetric clustering, in that all the system will be provided the same data and it will be executing at the same time. And the next type is real-time system. So the real-time system, it could be either hard or soft real-time systems. So real-time system is nothing but the controlling device based on a particular time period, that is called as real time system, and it can be used for real time applications like scientific experiments, for medical imaging systems. You are seeing x-rays, for operations they are using real time systems, industrial control systems, and some industrial control system is robotics, robots they are using for controlling certain jobs, and some display system. So everything comes under real time systems. That means it has a well defined fixed time constraints. The time constraint needs to be followed very strictly, and the real time system, either it could be a hard real time and soft real time. What is a hard real time system? So secondary storage will not be there. The secondary storage devices are compact disk and pen drives. So all these are not available. The information will be stored only in read only memory or ROM. And the soft real time system, it has some limited utility. Not all the industries are using, particular industry are using it, especially robotics, for robotics, and it can be communicated or combined with time sharing system also, and it is mainly used in multimedia virtual reality. It requires some tight response. Movies comes under real time systems. And an example is given. If a missile is under real time, it is used in real time system, means the missile needs to reach the target at a particular time. If it is not reaching it, it is a failure one. So it is a hard real time system. And the DVD player is a soft real time system. It can be switched on and switched off according to the user thing. It doesn't have any particular time, stipulated time and all. So that's why it is soft real time system. And the next type of system is handheld systems. So handheld systems or personal digital assistants are called as handheld systems. Our mobile phones are handheld systems. Cellular telephones, the main it also needs some operating system. Android is the most powerful operating system. Currently they are using it in handheld systems, and it also has limited memory. It also has some issues like limited memory. You cannot, if you want some more memory, you have to add some hard disk or something, and slow processor. It is a slow processor. So you cannot compare this handheld system with any other computer system, and it also has small display screens. Within that screen only you have to watch your contents. So all these are issues under handheld systems, and that's all with types of systems. And we are going into the next topic, common system components which are available in the operating system. So these components are controlled by the operating system, which is available in all computer systems. Process needs to be managed, main memory needs to be managed, file needs to be managed, IO system needs to be managed, secondary storage devices needs to be managed, networking protection needs to be given to the system, and also for all the basic resources and command interpreter systems. All this comes under common computer system components, right? And what actually operating system do for process management? What is a process? What is a process? A process is nothing but a program which is in execution. What is a program? A program is nothing but an instruction given to the computer to execute a particular job. If that program is in running state, then it is called as a processor. See, a process definitely needs some resources like CPU, memory files, IO devices, and everything to finish its task. And the operating system is responsible for creating the process, deleting the process, suspending the process. If suppose any interrupt happens, it needs to suspend the process, and after some time it needs to resume the process. And process synchronization is at the same time running two or more jobs is called as process synchronization. So the OS is taking care of all these things, process synchronization, process communication. When one process is getting executed, the output of one process will be given as the input for the next process. So that communication is needed for a process, and it is handled by the operating system. And the next one is main memory management system. As you all know, memory is the large area where your content are going to be stored, and it has its own address, and it is otherwise called as a repository of having data. And main memory is a volatile storage device. So what is meant by a volatile storage device? Whenever the power fails, the main memory contents will be deleted. It is not a permanent one. So the operating system is responsible for doing managing this main memory by keeping track of which parts of memory is occupied and which one is free now, and also who is using that particular part, and at what time they have logged in, at what time they have logged off, what work they are doing. Everything will be maintained by the operating systems. And it also allocate the operating system only, it allocates the memory space for the user, and also it deallocates the memory space whenever it is not in use. And the next one is file management. So file is going to have all your contents. So the file will have the file is created only by the creator or the user, and the operating system is responsible for creating the file, deleting the file, and the files cannot be kept separately. Same type of files needs to be stored in a directory, so the directory needs to be maintained by the operating system. So it is the sole responsible for creating the directory, deleting the directory, and also it supports some primitives. Primitives are nothing but the rights given to the files and directories, whether the user can read the file, write the file, or he can execute the file. So the permissions needs to be given by the operating system only. And mapping the files onto secondary storage device. Suppose if the main memory is not available to store the file, if it is full, or the file is not needed often, so we are going to store it in the secondary storage device. So the mapping of secondary storage device to the memory, whenever the file is needed, it needs to swap in the files from the secondary storage device to memory, and whenever it is not needed, it needs to be swapped out to the secondary storage device. So everything taken care by the operating system. And also it takes care of backup. So backup is needed whenever the file gets deleted accidentally, or because of some unauthorized user, it will be deleted. So this deletion, if the file is deleted, you cannot take the contents. In order to make it in a safe way, you need a backup of every file whatever you are using every day. So that file backup is also taken care by the operating system. And I/O system management. So I/O is nothing but input output devices. So every input output device which is connected to your system, it needs some special hardware devices. So and it also needs a specific hardware device. If it is an inkjet printer, inkjet device driver is needed. If it is a laserjet printer, a laserjet device driver is needed. And also every input output system will have a buffer catching system. That means if you have taken a file for printing, or if you have given a print command for a file, even if you close that file, it gets printed. How it is possible? Because the I/O system manager will have buffer cache memory. So that in that buffer cache memory, whatever file you want to print, that will be stored in it. So that's why even though you close the file, it gets printed in the printer. And that is also managed by the operating system. And what is secondary storage management? Secondary storage is our compact disk drives and also pen drives comes under secondary storage device. We need a backup for it. That's why we are using secondary storage device, as I have already told you. And it is the operating system is responsible for managing the free space in secondary storage devices also, and allocating a particular content to that secondary storage device and scheduling that particular file into the disk. So everything needs to be taken care by the operating system. So without operating system, none of the components will gets executed in our computer. The computer is it's like a dumb monitor, right? And networking. Next one is networking. So distributed systems needs to be connected through some of the network. Already I have told you. So each processor will have its own local memory, and they have communicated or they have connected through some network. And a protocol will be used for each and every network. If it is a LAN network, a protocol is used. If it is a WAN network, a protocol is used. So according to that protocol only, the operating system will communicate to the distributed systems, right? And the information, as it is a distributed system, the information needs to be shared to the other system. So as it is sharing, the speed will be increased, data will be available in all the system. Even though one system gets stopped its execution, or some failure happened to one system, the other systems can manage. And enhanced reliability is also there. And everything is maintained by the operating system. And what is protection? So protection is the main thing. Even though it is working, even though a computer system is working properly and our data are hacked by some other people, then our system is a failure one only. So the protection needs to be properly given to all the components by the operating system, and the protection is given for unauthorized, not only for authorized user, unauthorized user also. That means if the unauthorized user is entering into the system, the operating system needs to say no to that particular user. So that's why the protection needs to be given for not only for the authorized user and also for the unauthorized user. And specify the controls to be imposed. So whatever control needs to be given to a particular content, that is also specified by the operating system. And everything is executed, whatever controls or whatever rights have been given or whatever protection have been given, that is imposed only by the operating system. If the operating system is failed, anyone can enter and anyone can access whatever they want. Right. And the next one is command interpreter system. So command interpreter system is you can execute the operating system with the help of giving commands. So the commands can be given for accessing, process creation, IO handling, secondary storage management, main memory management. Everything is controlled with the help of some commands given to the operating system. The command is given by the user only. So the user needs to know the command, what command needs to be given to the operating system. So overall, operating system is not a bigger thing. It is also developed. It is also a program developed by the user. Right. And what are the services done by the operating system? So the services is it executes the program. So I have typed a program in C or C++ or Java and I have saved it, but if I am not giving execute, the OS will not execute it. So the execution is completely done by the operating system. And IO operations. So IO operations are nothing but input output devices needs to be allocated. It needs to check before the process gets executed whether it is properly connected or not, or some error message needs to be given to the user. Everything is done by the operating system. And file system manipulation, managing the files, writing, creating, deleting, everything needs reading, everything is managed by the operating system. And communication, it is helping for communications, like one process needs to communicate with the another process through a network, that is done by the operating system. And error detection, as I have already told you, the error will not be only in input output devices, it could be in memory. If the memory space is full, it is showing the memory space is full, please delete some files. So all this error detection needs to be done by the operating system only. And some more functions regarding system side is resource allocation. So what is resource allocation is the basic resources needs to be allocated for the particular processes. So that is done by the operating system. And accounting is every time once the process gets executed, it needs to check whether the resources have been properly allocated, whatever resources are allocated, whichever resources are free and which can be which needs to be deallocated, everything needs to be maintained as an account, and that account needs to be checked by the operating system. Then only it will execute in a smoother way or an effective way. And protection, ensuring that all access to system files are available. So basically a computer system will have a system program and also a application program. An application program is actually installed by the user only, but the system program is already available in the system. So the system program cannot be disturbed by anyone. It should not be disturbed because it is already stored. Once if it is disturbed, the application programs cannot be run. Even though you have written a proper code, even though you have written in a proper environment, it will not work without the execution of the system programs. And next we are coming to the concept of process. So completely we are going to see how a process is managed by the operating system. So what is a process? Already I have told you, a program which is in execution state is called as a process. And it could be the process could be a batch jobs. Batch job is similar jobs are grouped together, that is called as batch jobs. Or it could be a time shared system. So for a particular time a process will work, after some time the next process will work, that is a time shared systems. So textbook actually the process includes program counter, stack and data section. So what is a program counter? So program counter will have the next instruction that needs to be executed. So if a first instruction is getting executed, the program counter will have the number of second instruction that needs to be executed next. So the program counter will have the number 2. That means the second instruction needs to be executed. Okay. And what is a stack? A stack is a storage space for storing the data which is used by the programs. The stack will have you can enter whatever data you are entering through input devices, that will be stored in the stack, and whenever it is needed for execution, that will be taken from the stack only. It is a storage area, and it is also a temporary storage area. And data section. So data section is going to have all the data grouped together. So whenever operating system needs some data for executing a process, it is going to check only the data section. And process state. So every process needs to have a process state. Why we need a process state? See, if suppose a process is getting executed and for some interrupt the process gets stopped. So the OS doesn't know in which part it needs to start the process, restart the process again. So for that a process state is needed, because we cannot assure that operating system will execute only one process at a time. So as Windows is a multi-processing, we are executing Word, at the same time we are using Excel, at the same time we are using PowerPoint. So any number of processes can be executed by the operating system. So we cannot say that if a process gets stopped, it should not be restarted, or it should not be executed. Okay, right. And what are the states available in process? It's a new state. New state is the state whenever the process is first created, being created. If it is in a being created state, then it is a new process. And running state. So what is a running state? If the process starts executing, the instructions will be started executing. So that state is called as running state. And waiting state, if the process is waiting for some input, or it needs to print some output. If it is waiting for some input or output devices, then it is called as waiting state. And what is ready state? If the process is ready to be allocated to the CPU for execution, then it is called as a ready state. Once the process is in ready state only, it will go to the next state of running state. And terminated state, once the process gets completed with its all operations like IO operations and everything, any calculations, everything is over, then it comes to the terminated state. Right. So this is the process state diagram. So initially it is new state, and it will be, the process will be taken to ready state. So the CPU will check only the ready state of the process, then only it will start its execution. So if the process is in ready state, the scheduler is going to dispatch the process from the ready state to running state, and the process will be executed. At the time, if any interrupt comes, it will come to the ready state again. After the interrupt gets over, again it needs to be sent to the running state. Or sometimes if it is waiting for any input output devices or any event to be occurred, event could be any small, it could be a forking process, that is a child process needs to be executed. So that time it needs to wait until it gets executed. So it is in waiting state now. After that, after completion of IO or event, again it will taken to the ready state, and it start from that ready state, it will be taken to, the scheduler will take that to running state. Once everything is over, the process gets terminated and it will go to the exit, that is it will go to the terminated state. So these are the 5 states available for each and every process we are executing on the computer system. And so the state informations will be stored in the process control block. So what is a process control block? It is going to maintain about the process. The process control block is going to maintain about the process details. What are the details it will maintain? Process state, in which state it has been stopped, whether it is in running state or ready state, in which state it has been processed, that is called it has been stopped, that is called as process state. And program counter, what is the next instruction needs to be executed after resuming the process, and that will be maintained by the program counter. And CPU registers, as you all know, the information, the data will be stored in registers as hexadecimal numbers, and you have so many registers, ABCD, pair registers, ABCD, everything. And CPU scheduling information. So CPU scheduling information is when this process can be executed, whether the CPU is ready to execute or not. So that information is also maintained by the PCB. And memory management information. So where the data is stored, where the program instructions are stored. So in which instruction it has been stopped. So all the memory informations will be maintained by the PCB, or it will have the information about the memory for the particular process in that PCB. And accounting information, and also IO status, input output status of that process, that will also be maintained by the PCB. So PCB is going to have the process state, program counter, CPU registers, and CPU scheduling information, memory management information, IO information, and accounting information for each and every process. And this is the diagrammatic representation of the process control block. And this diagram tells you the CPU switch from process to process. See, take an example, if two processes executing P0 and P1. So when process P0 is in executing state, process P1 will be in the idle state. So when process P0 is executing, at that time some interrupt or system call has happened. So the state will be saved in the PCB, that is PCB 0, that is for process P0. And after everything is over, it will reload when P0 process P1 needs to be executed. The state information of the PCB1 that is for process P1, that will be reloaded again, and it starts executing. That's why you are seeing an executing state for the process P1. And when some interrupt or system call happens for the process P1, again the state will be state of process P1 will be stored in the PCB, and after that again if P0 needs to be executed, the state of P0 will be reloaded and it starts executing. So whenever the process is not in executing state, it will be in an idle state. And process scheduling queues. So what is process scheduling queues? So if as we all know, it is a multi-processing or multi-programming environment. So more than one process will be executing. That means every process, when every process is coming at the same time or at the same milliseconds, it cannot be allocated. The CPU will not start executing all the programs. So it will maintain a queue, and in that queue it will place all the jobs, and whenever needed, process and jobs are the same. So whenever a particular process or job needs to be executed, it will take it from the queue and execute it. So it is going to maintain, the OS is going to maintain 3 types of queues. One is job queue, ready queue and device queue. So what is a job queue? Set of all jobs available, whatever jobs available for executing for the operating system, that will be in a job queue. What is a ready queue? So whichever job is ready for execution, then all the jobs will be placed in the ready queue. So from job queue, again it will be transferred to the ready queue. And once the process gets started executing, it will be asking for some IO devices. Already we have seen in the diagram. So it will be asking for some input output device. So that time it is in waiting state. So that input output device asking process will be more. It will not be only one at a time. So that the device needs to be maintained some queue. So that particular process which is asking for output device will be placed in the device queue. And the OS will help the CPU to migrate from each and every queue. And how the ready queue executes and how various IO device queues are executing, it has been given in this diagram. So you are seeing so much of queue headers. What is the head ready queue? All these 4-5 queues are for all these 4-5 processes are in ready queue, and each and every process is having some magnetic tape, some disk or terminal, and each thing will be having some process like PCB7, that is process 7, PCB2. The first ready queue is having PCB7 and PCB2. Everything is interconnected. Once PCB7 is executed, it will automatically move to the next process, PCB2. So similarly, the end of the process, whichever process is end for that particular queue, you will have that information in the tail part. The head part is going to have the starting process which needs to be executed, and the tail part is going to have the ending process with that ready queue. And if you see in the second queue, you won't be having anything. That means no process has been allocated for that queue. And third one, fourth one and fifth one, so some processes are allocated both in head and also in tail. According to that order, it is going to take one process and start its execution. Right. And how the process scheduling is given. A process can be scheduled in this way. So everything will be placed in ready queue, and whenever the CPU needs, it will fetch the job from the ready queue and do its execution. So sometimes whenever it doing its execution for a particular process, it could be asking for some IO. If IO is requested, it will be placed in the IO queue. After the IO is given, again it will be placed in the ready queue. From the ready queue only, CPU will take the process and execute it. Or sometimes the process which is getting executed, the time slice will be expired. If it is a time sharing process, the time slice might be expired. So that time again it will be placed in the ready queue. And sometimes it will be asking for a child process. So the sub process needs to be executed. So after that again it will be placed in the ready queue. Or sometimes the process which is executing is waiting for an interrupt. After the interrupt has occurred, again it will be placed in the ready queue. So from the ready queue only, the CPU will take the jobs and execute it. And how the jobs are taken from the ready queue to CPU. So for that we are using schedulers. So the schedulers could be a long term scheduler or a short term scheduler. You are also having medium term scheduler, I will tell you that. So what is a long term scheduler? Long term scheduler is otherwise called as job scheduler. So selects which process should be brought into the ready queue. That means so many processes are come to the CPU, so many processes has been come to the system, and which process needs to be selected to place in the ready queue, that is decided by the long term scheduler or job scheduler. And the short term scheduler, it is otherwise called as CPU scheduler. So I am having so much of process in ready queue, which process needs to be allocated to the CPU for execution, that will be decided by the short term scheduler or CPU scheduler. And you also have a medium term scheduler. So what is the work of medium term scheduler is whenever a process is being executed and some interrupt has happened, or for some reason some other process has been given some priority. So the OS will take the priority of the jobs also. If we have given the more priority for a particular process and it has come for execution, means it will stop the process which is being executed, and the partially executed process will be swapped out, and when that particular process which has been given the highest priority will be executed, and after that again it is swapped into the ready queue for further execution. So that is done by the medium term scheduler. And the short term scheduler will be very fast, and long term scheduler might be very slow. And the long term scheduler, it controls the degree of multi-programming. What is meant by degree of multi-programming? Multi-programming is more than one processor execute at the same time. So if you are having 1000 programs needs to be executed, if it is possible, it can be executed. If it is not possible, instead of keeping all the 1000 jobs in the CPU and make it to execute, it will stop its execution, the system will get failed. Instead of doing like that, it will maintain a particular queue. For example, this system can execute only 100 jobs at a time. That means it will allow only 100 jobs to get executed. That is called as degree of multi-programming. And the process can be divided into two types. One is IO bound process, another one is CPU bound process. IO bound processes, that process will be always asking for input output devices. So that process always will be in IO queue. So that is called as IO bound process. And CPU bound processes, it doesn't need any input output devices. Particularly it needs only the execution, that is calculation needs to be done for the particular process. So that type of processes are called as CPU bound process. And what is a context switch? Whether it is very healthy of moving a job or a process from ready queue to CPU often? No, it is not healthy. So the moving of jobs or process from ready queue to CPU, then it is called as context switch. Whenever you are moving, it means it is called as context switch. So it is it's a overhead for even operating system also. If more number of jobs are switching again and again, the operating system will deteriorate its execution. So when the operating system does this context switch, it will not do any other useful work. It will particularly check for the state of the process which needs to be stopped. It needs to store it in the PCB, and it needs to check for the state of the process which needs to be executed now, and it needs to be stored in the PCB. So everything needs to be done by the operating system. So it will not do any other jobs. So it is a overhead thing, and not all the operating system will do that. It is having a separate hardware, and if you use that hardware only, the switching process will be done automatically, right? And what is a cooperating process? So cooperating, you have two more types of process, that is independent process and also cooperating process. Independent process cannot affect or be affected by any other process. It gives a individual performance. That means if the process gets failed, it's failed. If the process is executing completely, yes, it is executing completely in a better way. What is a cooperating process? So cooperating process is whenever a process gets failed, it will affect the other process which is executing. So what happens? All other process will also get stopped. So that is called as cooperating process. So the independent process will not affect other process. Cooperating process will affect other process also, right? And what is the advantages of using cooperation process? It also has some advantages. Even though it affects other process, it also has some advantages, like information can be sharing. If it is an individual process, okay, I can accept that if it fails, it is going to affect itself only, it is not going to affect other process, but still the process doesn't share its information to other process. But in cooperation process, the information will be shared, and the speed up is also done, and convenience of process is taken care by the cooperating process. If this system is not convenient for that process to execute, you can even share that information or share that process to some other system which is convenient. So the convenience is more. And modularity. Modularity is nothing but not a particular system needs to execute all the 1000 instructions at the same time. Instead, you can divide the instructions as hundreds and hundreds, and you can use it for 10 systems. So at the same time, the speed will be more. The 10 systems will be executing at the same time, so the results will be given very speedy, right? So they are taking as an example producer-consumer problems. For that, producer-consumer problem is used. What is producer-consumer problem? So whenever a producer is producing a particular item, the consumer can consume it. If the producer is not producing items, then the consumer cannot consume it. If the consumer is not consuming the items, the producer cannot produce it. So that is the problem. That means that is the cooperation is needed between the producer and the consumer. That is what we are going to say. And it also finds a bounded buffer. It also has the producer consumer problem will have buffers. Buffers are the temporary storage areas to store the data. That means the items which is produced or consumed by the user will be consumer will be stored in that buffer. So that buffer can be divided into two types, unbounded buffer and bounded buffer. If it is an unbounded buffer, there is no limit of storing that particular item which is produced or consumed. For bounded buffer, there will be a limit. So within that limit only the items. That means if the producer is producing 10 items per day, only if the 10 items gets consumed, he will produce the next item. So the 10 is the limit which we are giving for the buffer. So that is bounded buffer. And inter-process communication. So in process, you have a better facility, that is inter-process communication. So what we are doing? Chatting. So chatting is a inter-process communication, right? So mechanism for process to communicate to and to synchronize their action. In order to make it convenient way, the process needs to be synchronized together. So that synchronization is possible only if you use the IPC, that is inter-process communication. So how it is communicating? Through some messages. So the messages could be of two actions. One is sending, another one is receiving. One process when sends a message, then it is sending the message, and when one process is receiving the message, then it's a receiver. So it could be the communication link is needed between a process to send and receive the information. And that communication link could be either physical or it could be a logical one. So if it is a physical one, you will have some buses or a LAN connection, WAN connection is made. So that is physical connections, or it could be a logical connection. So you can give some message. If that message is passed, then it is or some variables is hold, and if that variable value is passed, the link has been done. So it could be a physical one or it could be a logical one. And when you are using IPC, certain questions you have to solve, then only you can give a communication link. So what are the questions? Whether links can be established between these two systems or not. So we have to identify that. And the next one is whether we can give only one link or more link can be given between these two processes. That should be identified. And the next one is what is the capacity of the link, how much messages can be passed between these two processes, that is the capacity. Or it could, if the message could be a fixed message or a variable message, the link can pass a fixed message or a variable message, whether the link is a unidirectional or bidirectional. That means if a process A is communicating with process B, whether process B can communicate with process A or not, that should be identified. If all these questions are answering properly, then you can give a communication link between two processes. And it could be of two types. One is direct communication and another one is indirect communication. So direct communication links are established automatically, the communication link will be there, and exactly one pair of communication will be there. At one time, one pair can be communicated. If P is communicating with process P is communicating with process Q, that means one pair can be communicated at the time. And between each pair there exists exactly one link. You cannot give more than one link. Exactly one link can be given. And the link can be maybe unidirectional, you can also change it to bidirectional. Unidirectional is only P can send information to Q, Q cannot send it back. And two properties or two commands are used, one is send command, another one is receive command. And what is indirect communication? Our mailbox is an indirect communication, it's an example. So how it is an indirect communication? That means if you are giving, if you are sending a mail, it is not that the receiver needs to be there to receive the mail. So it will be in the inbox. Whenever the receiver is opening the mailbox, he can be able to see the messages. That's why it is called as indirect communication. So links will be established within a mailbox, and many process can be executed, or many process can be linked. That means more than one person are sending the email to a particular person at the same time. That's why more link can be associated, and each pair of process may share several communication links. It is not that one link will be there, from that system only you can send message to or send mail to one person. It is not possible. So it is not the thing. Many different servers can send the mails to that particular mailbox, and the link can be either unidirectional and also bidirectional. So these are the advantages of using indirect communication. Right. So the indirect communication, you need to create a mailbox. Before doing that indirect communication, a mailbox should be there, and it needs to send and receive the messages, and whenever the mailbox is not needed, it needs to be destroyed. And the primitives or the commands used for indirect communication is again send and receive. Send is going to send the command to the mailbox, and receive is going to receive the command from the mailbox. And mailbox sharing is also there. P1, P2 and P3 share mailbox A. That means more persons will be using the same mails. So they are sharing the mailbox. P1 sends, P2 and P3 may receive. It is not that only for one person you can give a communication link. So more than one person can be communicated. That means I can give a message to mail to more than one person. So that is being given here, and for that you need some solutions. That means if you want to communicate like that, you need to do all those things. Allow a link to be associated with at most 2 processes. So you have to allow the link. So we are we are giving the link, so that link needs to be allowed for 2 people, and one process at a time to execute receive operation. Allow only one process. That means if you are sending a mail to process P2, at the time P2 needs to receive it, and after that P3 will receive it. So one by one it is going to receive it.